So today we are going to be discussing the oxidation states of elements. And in order for us to understand it very well, I'm going to be using the electronic configuration of atoms to explain this in a way that all of us will all understand. So what you simply need to do is, first of all, you need to know the atomic number of each of these elements. Like I'm going to be explaining the oxidation states of elements from elements from 1 to 20. Okay, and you are required to know the elements from 1 to 20 for you to know the oxidation state. Okay, or if you do not know it, you can refer back to your periodic table. But then, even with the periodic table, you should be able to tell the oxidation state just by knowing the group. I will explain all that in this video. So, but before I continue, if this is your first time of coming across my video, kindly subscribe to my channel so that each time I post, you'll be the first person to see the video. So, supposing you have been asked to find the oxidation states of these elements, A being calcium, B being aluminium, and C being fluorine, fluorine. So, how do you find out the oxidation states? Am I correct? So, the first one being calcium. What we simply do is to draw the electronic configuration of calcium. Okay? Now, calcium is represented by capital letter A, C, and small letter A as a symbol. And the atomic number is what? 20. You need to know the atomic number of calcium for you to be able to know the oxidation state using the electronic configuration. Okay? So, the first shell actually takes a maximum of 2 electrons. Second one takes a maximum of 8. But then, we're going to 20, right? So I've only drawn 2. So the second shell will have pairing of electrons, okay? We have the electrons being paired. That is 2, 4, 6, 8. Plus 2 inside, making 10. We are still not up to 20. So add an additional 8 again, which will still not be up to 20. This is 18. That is 2 plus 8 is 10. 10 plus 8 is what? 18. Then we have the last one, the last shell. We have 20 minus 18 with 2. So the last one will be what? 2 electrons. This is the representation of elements. Sorry, atom of an element using electronic configuration. Okay, so this is calcium. This is it. So for us to know the oxidation state simply means the number of electrons in the atomos shell. And the number of the electrons in the atomos shell is 1 and 2. So the oxidation state of calcium is equal to what? 2. It's as simple as that. So I've done that of A. Let me go move to B. For B, B is aluminium. Aluminium is represented by capital letter A and small letter L, and the atomic number is 13. Okay? As I mentioned earlier, it is important to know the atomic number before you be able to draw the electronic configuration and then find the oxidation state. So the atomic number of aluminum is 13. So the first shell takes 2, second shell takes a maximum of 8. This is 8 outside. So we have 2 plus 8 is 10, but we're going to 13, right? 13 minus 8 is 3. That means we have 3 electrons left to be drawn. And this is 3 electrons. The oxidation state, as I mentioned earlier, is the number of the electron in the outermost shell. And this is the outermost shell. The shell we have at the outermost, and this is 3. So the oxidation state of the oxidation state of aluminium is what? Is 3. Just as we have it, 1, 2, 3. So we'll move to the next one, which is fluorine. Fluorine is represented by capital letter F, and then the atomic number is 9. So for us to draw the electronic configuration, we start. The first one takes a maximum of 2, while the second shell takes a maximum of 8. But then if we draw 8 here, if we put 8 electrons here, it should be 8 plus 2, which is what? 10. But we have 9 here. So that won't be possible. So what you simply say is 9 minus 7. Sorry, 9 minus 2, which is 7. So we draw. This is 4, 5, 6, 7. So it's complete now. So what is the oxidation state of fluorine? The oxidation state of fluorine is equal to what? Is what? Is now, this is where it becomes a bit tricky. Now, what I didn't tell you in this one, this two, is that metals will ionize by losing electron or donating electron. Okay? So that's why in group 1 to group 3, they are all metals, right? Except hydrogen. But then, for non-metals, we start from where? From group 5 to group 7. They are non-metals. And what they do is that they accept electron. They do not donate. Instead, they accept electron. So when you get to that case, for example, where you have fluorine here, what you simply say is, since the number of electrons in the outermost shell is more than 3, it is no longer a metal. So if it is more than 4, if it is 4, it is metalloid. Then if it is more than 4, it now becomes what? A non-metal. In this case here, we have 7 outside. So how do we know the oxidation state? The oxidation state will now be what? The obtainable number of electrons can have in the outermost shell, which is 8, minus what? 7. So therefore, the oxidation state is 1. But then, it's actually supposed to be 7 minus 8 anyway. So you have what? Minus 1. So therefore, the oxidation state of fluorine is what? Minus 1. So if this tutorial has actually helped you, I implore you to share to other people so that they can also participate in this lecture. Bye!